Okay, hi students, welcome to our YouTube channel again. So last time we did 5 questions of GCSE paper, the foundation paper, June 2018. So today we are going to start the next part of that paper from question number 6. The question is, a student investigated the electrolysis of different substances and the apparatus is given, and explain why electrolysis would not take place in the apparatus shown in figure 6. So if you see in that apparatus, so here the electrodes are made up of graphite, and here the solid zinc chloride that is used. So actually that is the mistake here in this apparatus, because for the electrolysis we need, instead of solid, here it should be in molten state or aqueous form. So that is the problem. That's why the electrolysis would not take place in the apparatus that shown in fig 6. Okay, now the question number 6.2, that is very important question. Like, explain why graphite conduct electricity. Answers in terms of structure and bonding in graphite. So as we know that the graphite also like formed by covalent bond, because in the graphite that is containing covalent bonding, but the graphite is the only compound that conduct electricity. But as we know that the covalent compound that do not conduct electricity. But why the graphite conduct electricity? So here the answer is actually the graphite. For example, here is the graphite, the carbon of the graphite, and here is the second carbon, and here is the third carbon. So now here, as we know that the carbon, the outermost shell of the carbon containing 4 electron, and the carbon has ability to make 4 bonds. But in graphite structure, each carbon atom form 3 covalent bonds instead of 4. For example, here 1 covalent bond, second covalent bond, and third covalent bond with that other carbon. But here you can see that 1 electron per carbon atom is delocalized. 1 electron per carbon is delocalized, because here the carbon will not make the 4th bond with other carbon. So here that electron per carbon is delocalized. So these electrons carry charges through the graphite. Like for example, here is the electron, here is also electron, and there are the number of electrons. So why? Because the graphite contain like a number of carbon atoms. So these electrons move through the structures, so they have ability to conduct electricity. So that is the answer. Okay, now the next one, the student investigated how the volume of the gas produced changes with time in electrolysis of sodium chloride solution. So figure 7 is given, the apparatus that is present here. Now the question is, the student made an error in selecting the apparatus for this investigation. How should the apparatus be changed? Give one reason for your answer. Like for example, if we see here that instead of measuring cylinders, here is the use of test tube, and we know that for measuring the gas, for collecting the gases like chlorine gas and hydrogen gas, So there will be no use of test tube. Why? Because the test tubes have no scales, and the test tube cannot measure volume. Okay, so here instead of test tube there will be use of measuring cylinders. Instead of test tubes. Okay, so the next okay, so here is the another student use the correct apparatus. This student measure the volume of the gas collected every minute for 20 minutes. So fig 8 that is given. Now if we see that there is the graph in between the volume of the gas collected in centimeter cube and time in minutes. So the question is describe the trends shown in the result. So as we see here that the hydrogen gas, or you can say the volume of the hydrogen gas, is directly proportional to time. So the first trend, that is the volume of hydrogen gas is directly proportional to time. That is the first one. Like you can say like the point that we can conclude it. Okay, the next one, that is like for example if we see the next one, up to 8 minutes chlorine is collected at an increasing rate. Like up to 8 minutes chlorine is collecting as an increasing rate, but after that, after 8 minutes, the rate of the collection of chlorine is the same as the rate of the hydrogen. So that is the another one we can write here, like the rate of the collection of, like you can say up to 8 minutes the chlorine is collected at an increasing rate, but after 8 minutes the rate of the collection of chlorine is the same as that of hydrogen. So that is like we can write here. Okay, now next one, 6.5. The number of moles of each gas produced at the electrode is same. No gas escape from the apparatus. Suggest one reason for the difference in the volume of each gas collected. So as we know that chlorine can react with the water, because chlorine can react with water, or you can say that the chlorine dissolve or that will in the form of solution. That is the reason in which like no gas escapes from the apparatus. Okay, now 6.6. Calculate the amount in moles of chlorine gas after 20 minutes. Use fig 8. So here after 20 minutes, if we see after 20 minutes, So the volume of chlorine gas is approximately 6.6 centimeter cube. So first of all, we need to convert this into decimeter cube. For that, here we have to divide 6.6 divided by 1000, and then the answer will be 0.0066 decimeter cube. So here it would be dm cube. So that is the volume of chlorine. Now we need to find, here the question is the volume of 1 mole of the gas, like we need to find the calculate the amount in moles of chlorine. So here n is equal to 0.0066 divided by 24.0. So the answer would be, like give your answer in standard form. So here when we calculated it, so that will equal to 2.75 times 10 to power negative 4. That is the answer. Okay. Now the next question, question number 7. Question number 7 is, this question is about group 7 element. Chlorine is more reactive than iodine. Name the product formed when chlorine solution react with the potassium iodide solution. As we know that the reactivity increase, like for example fluorine is most reactive than it like the chlorine, then iodine, sorry, after chlorine, first fluorine, then chlorine, then bromine, then iodine. Okay, so it means that the chlorine is more reactive as compared to iodine. And name the product form when chlorine solution react with potassium iodide. So for example here is Cl2 react with Ki, it will form what? Name the product. So here when chlorine is more reactive than iodine, so chlorine has ability to displace the iodine, so it will form potassium chloride here, and iodine will be eliminated from potassium iodide. Okay, so here the new product is potassium chloride. Now the balance it, so that is the answer. So it means here we have the products that are potassium chloride and iodine. Okay, the next, explain why chlorine is more reactive than iodine. So here are the many reasons, but here you can write that the chlorine's outer electron, like chlorine has like you can say the atomic the mass, or the atomic mass is also like less than as compared to iodine, because like you can say the atomic size of the chlorine is smaller than atomic size of the iodine. Like atomic size is smaller of chlorine is smaller than iodine. Or you can say like why the chlorine is more reactive, because the outer electron, chlorine's outer electron is closer to the nucleus as compared to iodine. And you have to write that the chlorine has ability to gain electron more easily as compared to iodine. So chlorine here chlorine gains electrons more easily. Like gain electrons, sorry. Okay, so chlorine gains electron more easily. So students, we can write any of them. Okay, now 7.3, that is chlorine react with hydrogen to form hydrogen chloride. Explain why hydrogen chloride is gas at room temperature. Like why HCl is gas. At room temperature. Like we have to write. Okay, so for this, as we know that the hydrogen gas is made of small molecule. The hydrogen gas is made up of small molecule, and hydrogen chloride, actually the hydrogen chloride is made up of small molecule, and hydrogen chloride HCl contain, or HCl has weak intermolecular forces. Intermolecular forces, and it means that the intermolecular forces require little energy to overcome. That is the answer. Okay, now that question is very interesting. 7.4, bromine react with methane in sunlight. So here the equation is given. Now shows the bond energies and the overall energies in the reaction. Calculate the bond energy X of CBr. Here we need to find CBr for the calculate the bond energy X for the CBr bond. So use fig 9 and table 3. Okay, now we are going to start. So first of all, you know that overall energy, like you can say the change in overall energy change, let's suppose we are going to represent by del E, that is equal to bond broken minus bonds formed. First of all, we need to find bond brokens. Like the bond brokens energy, that is, here I am going to write like B dot B. Okay, so here are, like as we know that during the reaction, the reactant bonds that will be break, and the new bond in the product that will be formed. So it means bond formed that will be actually the product's bond, and the bond broken that will be the reactant bonds. So first of all, if we see in the CH4, there are 4 CH bonds. So here we need to write 4, and the CH bond, that is the CH bond energy, that is 412. So 4 into 412 plus bromine Br bond. So there will be only one bond if we see in the structure, or if we see in the equation. So it means there will be only one bond, that is 193 energy. That, so when we calculated it, so that will equal to 1841. Now the bond formed, like B dot F. So here again there are 3 bonds of CH and 1 bond of Br. So here we need to write 3 bonds of CH, 3 into 412, and 1 bond of CBr. So we need to find that is X, and then the next one HBr, one bond of HBr, that the energy is 366. Okay, so that will equal to, like when we calculated it, so it will equal to 16,602 plus X, that is the bond form. Now here the overall energy change is minus 51, so we can write, like we can put the values, that is minus 51 is equal to the bond form, the bond broken, that is 1841 minus, and the bond form, that is 1602 plus X. And when we calculated it, so the answer would be 290 kilojoule per mole. That is the energy. It means that is the CBr bond. Okay. Okay, now the next question, question number 8. That titanium is a transition metal, and here the equations are present. Like that is the extraction process of the titanium. So suggest one hazard associated with stage 1. If we see in the stage 1, there is the use of like titanium oxide, carbon and chlorine. So as we know that the hazard related to chlorine are associated with chlorine, because chlorine is Cl2 is toxic. So that is the answer. Okay, now question number 8.2. Water must be kept away from this reaction in stage 2. Give one reason why it would be hazardous if water come in contact with sodium. As we know that the sodium we use in stage 1, like in stage 2 we use sodium. So sodium is like that, if we react with water, so it will form, or that will occur a very exothermic reaction, because that is very exothermic, there is a chance of exothermic reaction occur. Okay, and we know that the sodium, when the sodium react with water, because we know when the metal react with like the water, like for example the sodium react with water, it will produce hydrogen gas, and which is flammable. Okay, so which produce hydrogen that is flammable. Okay, so now the next question, suggest why the reaction in stage 2 is carried out in the atmosphere of argon, not in air. Because there is the use of sodium, and sodium has ability to react with water vapors and as well as react with oxygen gas, because the atmosphere air contain oxygen gas and water vapors. Okay, so instead of air we use like the argon gas for stage 2 reaction. Okay, 8.4. Titanium chloride is liquid at a room temperature. Explain why you would not expect titanium chloride to be liquid at room temperature. Because we know that the titanium chloride is actually the here like in the stage 2 the titanium chloride TiCl4, that is actually ionic compound, and most of the ionic compound, as we like already seen in the previous the questions like NaCl, that is like solid at room's temperature, solid at room temperature. But if we see here that the titanium chloride is liquid at room temperature, so that's why we would not expect titanium chloride to be liquid at room temperature, because the titanium chloride is ionic compound, and we know that the ionic compound has the greater, or you can say a very high melting point and boiling point. So that's why we would expect that the titanium chloride to be solid at room temperature. Okay. Now in stage 2, sodium displaces titanium from titanium chloride. Sodium atoms are oxidized to sodium ions in this reaction. Why is this an oxidation reaction? So because in the oxidation reaction, as we know that oxidation reaction is the reaction in which the electron loss. So here is the sodium lose electron. Okay, the next question, that is complete the Hoff equation for the oxidation reaction. So that is sodium. Here the oxidation reaction, so here the sodium will lose one electron. So here it will look like this. Like it will form cation that contain plus one charge. So by donating one electron. Okay, 8.7. That is in stage 2, 40 kg of titanium chloride was added to the 20 kg of sodium. Okay, so here the relative atomic masses are given. Explain why titanium chloride is the limiting reactant. As we know that the limiting reactant is the reactant that is used in that is used completely in the reaction. Okay, for example here in TiCl4, let's suppose first of all, and to measure the limiting reactant, so we need to find their moles first by using the masses that are given in the question. Like 40 kg of titanium chloride. So titanium chloride mass is 40 kg. Okay, and here was added to 20 kg of sodium. So sodium mass is 20 kg. So first of all we need to find the masses of each titanium chloride and as well as sodium. So here 40 kg mean 40,000 grams divided by titanium chloride, that would be TiCl4 molar mass, that would equal to 190. So you have to divide 190 here. So the moles of titanium chloride, that would be here 211 moles. But if we see in sodium, so sodium moles, that equal to the mass of sodium, that is 20 kg. So here it would be 20,000 grams divided by the mass of the atomic mass of sodium is 23. So when we divide it, so here the answer will be 870 moles. Okay, so we can say that sodium is in excessive because 870 moles of sodium is more than 844 moles needed. Because how? Here, because like the 211 moles of titanium chloride is less than, like for example when we compare it, so here we can see that 1 mole of titanium chloride and here the 4 moles of sodium. So we need to divide 870 by 4, then the answer would be like 870 divided by 4. So that would be 217.5. So we can say that here, because 211 moles of titanium chloride is less than 217.5 mole needed. Okay, the last question of this paper, that is for a stage 2 reaction, the percentage yield is 92.3%. So we need to find the theoretical or the maximum mass of titanium produced in this batch was 13.5 kg. Calculate the actual mass of titanium produced. So as we know that the percentage yield is equal to the actual yield divided by theoretical yield times 100. Okay, so here we need to find the actual yield. So actual yield, okay, so here the actual yield will equal to percentage yield times theoretical yield divided by 100. So here we can write the 92.3 times 13.5 divided by 100. So that will equal to 12.5. Okay guys, so here is the end of today's lesson. If you like our video, do subscribe, and thank you for watching. We'll see you in the next video. Goodbye.